All right, folks, thanks for coming today. Let's go ahead and get started. Just let me ask you guys a favor today. If my lapel mic goes out and you all notice it and I don't, just let me know real quickly so I can switch over the audio on the computer so that the folks who are participating remotely today don't lose all of the audio. All right. What I want to do today is finish up this section on the money supply process. We should have plenty of time to do that and work a few practice problems together. And that's actually what we're going to start with today let's do a quick kind of review question of that tests your understanding of the material that we talked about in the last class, which was this simple deposit multiplier. So let me flip over to this PDF file here. So this is one of the problems that I think is also posted on Blackboard. I want you guys to take a look at number 4. And if we have time today, we'll come back and also do number 3 together as well. So number 4 says, suppose that a bank with no excess reserves receives a deposit into a checking account of $10,000 in currency. If the required reserve ratio is 10%, first of all, what is the maximum amount that the bank can lend out? That's easy to compute. And if the bank loaned out this amount, what would be the maximum impact on the total money supply? Here, you're allowed to assume that other banks in the banking system wish to hold zero excess reserve, and that all members of the public keep their money in the form of checking account balances. When you see those assumptions made in a problem, that should signal to you, well, this is just a chance for me to apply the simple deposit multiplier that we talked about in the last class. That is, the change in deposits is equal to 1 over the required reserve ratio times the change in bank reserves. So why don't you take a minute to do both parts of that exercise, and then we'll work through it together on the document camera here. I think I have everything switched over then. The first part of this question should be really straightforward. If the required reserve ratio is 10%, what is the maximum amount that a bank can lend out if it receives a deposit of $10,000 worth of currency from a retail individual?
9,000.
The reserve ratio is 10%, and it has to keep $1,000 in the form of required reserves, and it could simply lend out the remainder, which would be $9,000 in this example. So the maximum that the bank can lend out here is 9,000. That's the easy part of the question. What's the slightly more difficult part of the question? Asks, what is the total impact on the money supply if this bank loans out all $9,000 and then through the process of multiple deposit loan creation, the money supply starts to expand throughout the rest of the economy? Well, here we want to just apply the simple deposit multiplier formula, which says that the change in bank deposits throughout the economy is 1 over the required reserve ratio times the change in reserves? Well, in this problem, what is the required reserve ratio? It's 1/10, right? So 1 over 0.1 times the change in bank reserves. Now be careful about this. This is the change in reserves throughout the entire banking system. So ultimately, when this bank receives a deposit of $10,000, all of those funds are ultimately going to enter into the banking system in the form of reserves, right? It's a $10,000 increase in bank reserves. And so the total change in deposits then would just be 10 times 10,000, or $100,000. Now be careful about this, because that's not exactly what the question is asking, right? The question asks you, how much does the total money supply change as a result of this deposit? The money supply is not exactly the same as checkable deposits, right? Remember, the money supply is equal to currency in circulation plus checkable deposits. So what this means then is that the total change in the money supply, delta M, let's call it, should be equal to the change in currency plus the change in deposits. Well, in this problem, what was the change in deposits? It was $100,000, right? But has there been any change in currency in circulation? Yeah. Retail customer had $10,000. She deposited into her checking account, which ultimately gets absorbed in the banking system in the form of reserves. That's not part of the actual money supply. So the change in currency here is actually negative 10,000. Sorry, I'm scrunching up the numbers here. In other words, the total impact on the money supply would only be $90,000. And you can see why I choose to type everything in PowerPoint. My handwriting is really pretty bad. Sorry about that. Straightforward enough? Now look, the reason why I wanted to ask you this was really for two reasons. It reviews the simple deposit multiplier formula from the last class, but it also is a nice contrast with the practice problem we did in the last class. Remember, in that one, the bank receives more bank reserves directly from the Fed through an open market operation. In that case, they can loan out all of those excess reserves, and it increased the money supply by the full change in bank reserves. In this problem, where does the bank receive its injection from? Not the Fed, but rather a customer that deposits currency. In the first case, there was no change in currency in circulation. In this problem, there is a change in currency in circulation, and so the effect on the money supply is not the full size of the deposit multiplier. It's a little bit less than that because some currency is now going out of circulation. Okay, you guys have any questions then about that one? Any of you all participating through Zoom have any questions about that? Okay, let me switch back over to slides. Just one sec. And we will pick up where we left off last time. Don't have too much more to go. All right, so understanding this simple deposit multiplier that we've talked about now at length is really an important first step in understanding the greater money supply process. Okay, that's ultimately what we're trying to accomplish here. But it's not the full story. All right, for reasons that we're going to discover today, the simple deposit multiplier greatly exaggerates the impact that a change in bank reserve has on the total money supply for a couple of reasons. And those reasons are traced back to some of the assumptions that we made in computing or deriving the simple deposit multiplier. The two assumptions that hopefully you guys saw this as we were going through the derivation was, first and foremost, banks in our example here never elected to hold any excess reserves. In this little example we did in the last class, where a loan was made by one bank and an investor redeposited that money back into a second bank, and on and on and on, every time we went from one bank to the next, each of those banks elected to hold zero excess reserves. They would loan out the maximum that they could and only hold the required reserves. All right? Banks don't always do that. In particular, we live in a day and age now where commercial banks are holding enormous quantities of excess reserves, and that can impact this money multiplier process. We also assumed that every member of the non-bank public never changes his or her currency holdings. In particular, we just assumed what? That every actual investor in our economy simply deposits all of those funds back into a checking account and never actually chooses to hold any of their money in the form of currency, but rather all money is held in the form of checking account balances. So excess reserves were zero and currency holdings were zero. All right? Neither of these assumptions is literally true, right? We know that in the real world, some banks hold excess reserves, and we all decide how much of our money we want to hold in the form of currency versus checkable deposits. What we want to try to accomplish today is really something pretty straightforward, in my opinion. What happens to the money multiplier, to this simple deposit multiplier formula in particular, when we relax these two assumptions? What if we allow banks to hold excess reserves? What if we allow people to hold currency instead of checkable deposits? Does anything happen to this money multiplier process? That's what we want to think about in today's discussion. Okay, let me focus on the currency aspect first. So if you guys remember from the example from last class, when an investor spends the loan that I believe was provided by Bank of America in that example for $100,000, all of those funds ultimately got deposited into a second bank. I think it was PNC Bank in our example, okay? What does your intuition tell you if the seller in that transaction decided to keep some of that $100,000 in the form of currency instead of keeping it in a checking account balance? What would happen, do you think, to the money multiplier process, to this process of multiple loan deposit creation in that case? If instead of redepositing all of those funds back into the banking system, we actually kept a portion of them in the form of currency, how would that affect multiple deposit expansion? Would it go up or go down, you think? Probably go down, right? And the reason is because funds that are held in the form of currency are not subject to multiple deposit creation, right? Banks can't loan out money that they don't actually receive. The more of our money that we elect to hold in the form of currency, the less banks have available to loan out to a second or a third investor, etc. So my point here is that once we account for the fact that people in the non-bank public actually want to hold some of their money in the form of currency, this money multiplier process is not going to be as large as the simple deposit multiplier would suggest. In the example from last class, it was 10, right? a $1 increase in bank reserves increases the money supply by $10. Well, that wildly exaggerates what the true money multiplier is. And one of the reasons is because it doesn't take into account that people actually do want to hold some of their resources in the form of currency. Let's go back to our example where we choose to hold zero currency. And instead, let's think of a case in which, suppose that PNC Bank receives this $100,000 deposit in some investor's checking account. But instead of PNC keeping $10,000 in required reserves and loaning out the other $90,000, ask yourself, what would happen to multiple deposit creation if PNC simply elected to hold the full $100,000 in the form of reserve? How many additional loans and deposits would be created after that point? None, right? In fact, this multiple deposit expansion process would stop immediately. If the first bank didn't make a loan that ultimately gets deposited into a second bank, which then another loan is made and gets deposited into a third bank, the whole process of deposit creation stops, okay? And so this is simply because the more excess reserves that banks elect to hold relative to their checkable deposits, the smaller the deposit multiplier will be, right? Funds that are held as reserves at banks are not subject to deposit creation. A bank has to loan out that money to other people in order for more deposits and loans to be created. Again, once we take into account that some banks are choosing to actually hold excess reserves, this money multiplier formula is going to be a lot smaller. It's going to predict smaller effects of changes in bank reserve on the total money supply. Okay. So this simple deposit multiplier, which again assumes that banks hold no excess reserves and that we hold no currency, is useful. It's not realistic, but it's useful in understanding how reserve creation leads to increases in loans and deposits. There's a reason why we talked about it first, okay? This deposit multiplier process is really at the heart of the money supply process. It's the central mechanism in our economy that is driving what determines the money supply, is this multiple deposit loan creation process. That's why we talked about it first, because I wanted you guys to develop that intuition. So it's useful in that regard, but it's not really realistic for the reasons that we've talked about today, okay? In order to derive a more realistic money multiplier, we want to do three things here. First, rather than establishing a link between reserves and deposits, that's what the simple deposit multiplier does, we want a link between the monetary base and the money supply. We're going to derive a formula that shows exactly how that will work. We also want to include in our money multiplier formula the effects of changes in the public's desire to hold currency relative to checkable deposits. Let's account for that behavior, that people actually want to hold some currency and not all of their money in the form of checking account balances. And we need to recognize, by the way, that our desire to hold currency might actually change if economic conditions start to change. It need not be stable over time. Third, we want to include the effects of changes in banks' desire to hold excess reserves relative to their checkable deposits. How does that affect the money multiplier process? Again, recognizing that this decision to hold excess reserves can sometimes change dramatically when conditions in the economy change. I'm going to show you guys some actual data for the US economy that makes this crystal clear before we leave today. Okay, questions so far? All right, so In order to incorporate the changes that I just talked about on the previous slide, I think the best place to start is to simply rewrite that equation that we discussed at the very beginning of the chapter, all right? And that was that the money supply, which I'm going to denote with a capital M, so let's be clear about these variables here. The total money supply is equal to the monetary base, which I'm going to denote capital B, times the money multiplier. Remember that slide at the beginning of this section that had those three boxes? The money supply was equal to the monetary base times the money multiplier. That's this equation here. The money multiplier is what links base money to the money supply. All right, first off, let me flip this equation on its head, okay? And what does it tell us? It tells us very simply that the money multiplier is just equal to the money supply divided by the monetary base. Can we go further? What is the money supply equal to? Go ahead, back row. And currency in circulation plus checking account balances or demand deposits, right? If we want to think about the money supply in terms of like M1, the two main components would be currency plus checking account deposits, which I'll denote D. All of this stuff down here at the bottom of the slide is going to define my notation, so everything is clear, okay? How do we define the monetary base? Again, that's the two main Fed liabilities. That's currency in circulation plus bank reserves or reserve balances, which I'm going to denote with a capital R, reserve balances of banks. So the money multiplier then is C plus D over C plus R. All right, we can expand that a little bit more by recognizing that bank reserves are really the sum of two things. They're banks' required reserves plus their excess reserve holdings. So RR is required reserves, ER are going to be excess reserves. All right, now here is a step in this derivation that may not be completely obvious at first sight. Remember, what we want to try to account for in our money multiplier process are people's preferences for their currency holdings relative to how much they want to put in their checking account balance. That is really what we care about is the ratio of currency to deposits. We also want the money multiplier formula to account for banks' preferences of holding excess reserves relative to their checkable deposit. So what I want to do in the next step is rewrite this formula, not in terms of C and ER, but rather in terms of C over D and ER over D. That is the currency to deposit ratio and the excess reserve to deposit ratio. Now, how the heck am I going to do that? Well, I'm just going to employ a little trick here. I'm going to multiply this ratio by a fraction that's really just 1. It's 1 over D in the numerator and 1 over D in the denominator. So I'm just multiplying that term by 1. But if I multiply through on both sides, what do you see? That the numerator now becomes the currency to deposit ratio plus 1 divided by the currency to deposit ratio plus the required reserves to deposit plus excess reserves to deposit. You guys see what I did there? I'm just dividing the numerator and the denominator through by D. We recognize that RR over D is just this required reserve ratio. That gives us our more realistic formula for the money multiplier. It's equal to the currency to deposit ratio plus 1 over currency to deposit plus the required reserve ratio plus the excess reserve to deposit ratio, where again, I've got all of these variables or terms here defined in that block on the bottom left so that no one is overly confused here. Okay, let's do a quick example to illustrate what we're talking about. Let's suppose that I told you that the amount of currency in circulation was $500 billion. We had $1 trillion worth of deposits in banks. The required reserve ratio was 10%, and banks were holding collectively $150 billion in excess reserve. Can you tell me what the money multiplier is going to be? Sure you can. Just take these values and compute these various ratios, right? What is the currency to deposit ratio? It's 500 over 1,000. The required reserve ratio is just 0.1. The excess reserve to deposit ratio is 150 over 1,000, 0.15. And so the money multiplier, if you just add those up, is a 1.5 over 0.75 or 2. So instead of a money multiplier of 10, like we saw in the last class, we see that the money multiplier is significantly smaller when we account for currency and excess reserves. How do we interpret this? A dollar increase in bank reserves would then increase the money supply by $2, right? A dollar increase in the monetary base multiplied by 2 leads to a $2 increase in the total supply of money. Now, the way the money supply is multiplied here is exactly the same as what we talked about before. Banks are receiving deposits, they're loaning to investors, money gets redeposited into the banking system, new checkable deposits are created. The only difference is that a lot of those funds are being sifted away into the form of excess reserves, and some of them are being sifted into currency. And that means that the deposit multiplier process is going to be much smaller. Just one other quick way of looking at this. Ask yourself, look at this complicated formula and ask yourself what happens to that formula if currency is 0 and excess reserves are 0. What do you get? If currency is 0, that's gone and that's gone. And if excess reserves are 0, what are you left with? 1 divided by the required reserve ratio, which is the simple deposit multiplier. This is just a generalization of what we derived in the last class to account for the fact that banks are holding excess reserves and the public is actually holding some currency. See how that works? Let me make a couple of quick points about the money multiplier formula, and then we'll go and look and do a practice problem together. So I'm just copying the formula from the previous slide. The first key point that I want you to look at to help kind of build your intuition about this is that the total money supply is going to increase in our economy for one of two reasons. Either the monetary base, B, goes up, or alternatively, the money multiplier goes up. So the total money supply can increase in our economy if the monetary base rises or if something happens that causes the money multiplier to go up. Either of those two things will affect the money supply. What's the relationship between the currency to deposit ratio and the money supply? If I told you that people suddenly wanted to hold more of their money in the form of currency, what do you predict happens to the money supply? If the currency to deposit ratio suddenly were to get higher. So all of us kind of lose faith in the banking system, and we start to withdraw our money from our checking accounts and we hold more of it in the form of currency. Hopefully your intuition tells you that the money supply is going to fall. Why? Because the money multiplier will fall. As we withdraw more of our money, that's less that banks have to loan out to other investors. And so deposit creation shrinks. Well, you can see that mathematically here. If C over D gets smaller, then the money multiplier is actually, if it gets bigger, if the currency to deposit ratio gets bigger, then the money multiplier is going to get smaller. What about the required reserve ratio? How does that affect the money multiplier? If the Fed came out tomorrow and said all banks are required now to hold 50% of their deposits in the form of required reserves, what happens to the money multiplier? It's going to shrink. Firms now have to hold, banks have to hold more of their deposits in the form of reserves. They're going to loan out less, and so the money multiplier gets smaller, right? This number here in the denominator gets bigger, so the ratio gets smaller, and the money supply will shrink. Reductions in the required reserve ratio should expand the money multiplier and therefore increase the money supply. Lastly, if there was an increase in the excess reserve to deposit ratio, what if all of a sudden banks start to freak out and they want to hold a ton of excess reserve because they think that there may be systematic risk in the economy, and banks are electing to try to stay as liquid as possible, and excess reserves go way up? What happens to the money multiplier? It goes down, right? Banks won't be loaning out as much, and if the money multiplier falls, the money supply falls. Keep that in mind when we look at some data here at the end of class. Okay, why don't you guys take a few minutes and try to work this one. So this is a pretty straightforward application of the money multiplier formula that we've derived in class today. Okay, so let's assume that bank reserves are 500 billion and currency is 400 billion. If banks are holding 80 billion in required reserve and the required reserve ratio is 10%, can you tell me what the value of checkable deposits is? And then part B, what is the value of the money supply? What is the value of the monetary base? And can you compute the money multiplier? Why don't you guys take just a couple of minutes and try to work through that one, and then we'll go over the answers together. Anybody help me out with part A? What would the value of checkable deposits be in this economy if bank reserves are 500 billion, currency is 400 billion, the required reserve ratio is 10%, and required reserves are 80 billion? Anybody get an answer for that one? What would checkable deposits be? So in these types of problems, what you want to do is utilize the definition of these ratios, right? What is the required reserve ratio? How do we define it? That's required reserves divided by what? Total checkable deposits. If we know what the ratio is, and we also know what the amount of required reserves are, we should be able to kind of reverse engineer what the value of checkable deposits is, right? Remember, little rr is required reserves divided by deposit. So required reserves is just total deposits times the required reserve ratio. Well, we know that that required reserves are 80 billion. We don't know what checkable deposits are, but we do know that the required reserve ratio is 10%. So if we flip this equation around, you can easily solve for deposits. It's 80 billion divided by 0.1 or 800 billion. Okay, how about the M1 money supply? So how do we measure the money supply? This should be super easy. It's just currency plus deposits, right? Well, we know what currency is. That was given in the problem. It is 400 billion. And in part A, we just figured out that checkable deposits was 800 billion. So the money supply is just 1.2 trillion. See how easy that was? I'm getting funny looks, squinting your eyes. I get the impression that this is confusing somehow. If it is, please ask. I'll try to explain it better. How about the monetary base? What's the monetary base equal to in this problem? Levi? Well, the monetary base is currency plus reserves, which is 400 billion plus bank reserves are 500 billion. That was given in the problem. And so we have 900 billion in the monetary base. Very good. Okay. Levi, that's your name, Levi? Okay. Did you figure out what the money multiplier is then? Yeah, 1.3. So there's a couple of ways to do this. The easy way, I suppose, is just recognizing that the money multiplier is the ratio of the money supply to the monetary base. 1,200 over 900 is 1.33. So every dollar increase in base money should increase the money supply by $1.33. Or you can do the brute force method, right? Plug all of our values of these ratios that we've been talking about into the money multiplier formula, right? So the currency to deposit ratio in our example was 400 billion to 800 billion. The required reserve ratio was 10%. The excess reserve ratio to deposits was 420 to 800. Well, how do we get that? We know what required reserves were. They're 80 billion, right? And total bank reserves was given in the problem as 500 billion. That implies then that excess reserves are 420 billion. Now, if you've done this problem right, you should get the same answer that you got in the first part here, 1.33. I got 1.5 over 1.125. Either of those methods works. I usually like the path of least resistance personally, so I will sometimes use this. But in other situations, you might only have information on these ratios, in which case you'll want to use the formal multiplier formula. Okay, you guys have questions about that? Anybody online have questions about that? I'm assuming they could unmute themselves if they want. Okay. All right, let's move on to the next slide and actually look at some data, which I think is interesting and will help provide a little bit more intuition about what's going on here. So we saw earlier in this section that beginning in the fall of 2008, so I guess 12 years ago now, In response to the financial crisis, some of you may have remembered that episode, the Fed started to greatly expand its balance sheet, right? We had a slide that showed the total size of the Fed's balance sheet earlier in this section. And the balance sheet increased dramatically, not because currency went up, but because reserve balances at banks went up. And reserve balances at banks went up primarily because the Fed was buying up a huge number of assets like mortgage-backed securities, the agency debt of Fannie Mae and Freddie Mac, other types of securities the Fed was also purchasing. As the Fed did that, and it injected bank reserves into the banking system, it also greatly expanded the monetary base, okay? The left graph over here shows you two variables with US data from 1990 through really just the past couple of months. The red line here is the monetary base, and you can see that in late 2008, it just kind of took off, right? It went from less than $1 trillion to about $4 trillion in just a few years. Now, the monetary base was on a downward trajectory the past few years, but starting in about 2019, the monetary base has started to expand more as the Fed has been trying to combat the COVID-19 recession, okay? Now, you'll notice that even though the monetary base went way up, the value of the money supply, which is the blue line here, M1, also went up, but didn't go up as much. Now, how can that happen? How can the monetary base go up dramatically, but the money supply not go up as much? Remember, the money supply, in theory, is equal to the monetary base times the money multiplier. So if the money supply is not going up as quickly as the monetary base, what does that tell us is likely happening to the money multiplier? It's going down. It's not stable. That changes in the economic landscape are causing big shifts in what the money multiplier actually is. That's what this green line is over here. So the green line I've calculated, again, using US data, the money multiplier, which is just the blue line divided by the red line. It's just the money supply over base money. Now, what do you see? From the 1990s through at least the first half of the 2000s, the money multiplier was on a downward trend. It was stable for the first part of the 90s, but then gradually fell. It was around 2.5 or 3, and then by the time that the financial crisis started, the money multiplier was closer to 1/2. But what happened as soon as the financial crisis got underway? The money multiplier collapsed, and it went from like 1.6 all the way down to actually less than 1. In other words, the money multiplier stopped being a multiplier and became a divider, right? When the money multiplier goes less than 1, then you're going to have these situations where the monetary base is actually higher than the total money supply. That explains why the money supply didn't expand as much as the monetary base. So clearly the money multiplier fell. Well, all right, let's dig a little bit deeper here. Why did the money multiplier fall? What was happening in the economy that caused the money multiplier to collapse so suddenly? Well, I think the best way to investigate that is to take our money multiplier formula and look at how the components of that formula changed over time. That's what I do here on the last graph. What are the two main ingredients in the money multiplier? The currency to deposit ratio and the excess reserve to deposit ratio. Let's look at the currency ratio first. That is the blue line. In the 90s and 2000s, the currency to deposit ratio was on the rise. People were electing to hold more currency relative to their checkable deposits. But around 2006, the currency deposit ratio began to fall and continued to fall throughout the financial crisis and the recession. Now, let's go back to our thinking about how currency and the money multiplier are related. If the currency to deposit ratio was falling, what would you expect to happen to the money multiplier? If people are holding less currency relative to their checkable deposits, then what happens to the money multiplier? It goes up. Although we saw that, in fact, during this period, the money multiplier was going down. So a falling currency to deposit ratio cannot explain what happened to the money multiplier. It wasn't our currency holdings that explained the craziness after 2008. It must be something else. What is the culprit, you think? I would say excess reserves, right? Before 2008, you had a couple of these little blips where banks would hold some excess reserves, but ultimately, what were they trying to do? They didn't want to hold any excess reserves. There's a cost to holding excess reserves, all right? The opportunity cost is what banks could get by loaning their funds out to somebody else. After 2008, the world looked very different. Banks were so freaked out by all of the risk and the huge losses that they were getting on their real estate-based assets. They greatly expanded their holdings of excess reserve. They shot through the roof. And what do we know happens to the money multiplier when the excess reserve to deposit ratio goes up? That's in the denominator of the money multiplier formula. The money multiplier will shrink quite dramatically as a result of that. So the reason why the money supply and probably also inflation did not occur during the financial crisis is because the money multiplier was falling even as the monetary base was expanding. And so the money supply didn't increase by more than this explosion in the monetary base. And that's because banks were holding huge amounts of excess reserves. And by the way, they're still holding a lot of excess reserves. And I don't think we're going to go back to this situation anytime soon, if ever. The Fed in recent years has made every indication that they want to live in a world where banks are holding a lot of excess reserves. And that's why they've gotten rid of reserve requirements. So we need to get used to this world here where excess reserves are high. Now, just to be clear, there's a couple of reasons why banks wanted to hold excess reserves after 2008. One of the most obvious is that around this time, the Fed actually started paying interest on reserves. Before 2009, if banks held money in their reserve account at the Fed, they earned no interest on it. After that, banks started to pay interest, and so that would incentivize banks to actually hold some of their resources in the form of excess reserves, particularly because bank reserves are risk-free. The Fed will always provide that money on demand. Another reason is that during the crisis, a lot of these banks suffered heavy losses on their mortgage-backed securities and other real estate type assets. And so they needed to recapitalize. And during that period, they wanted to remain as liquid as possible. They didn't want their assets tied up in illiquid products. And so bank reserves are almost perfectly liquid. One other point I want to mention here is that during the financial crisis, banks themselves started tightening their lending standards. It was easy to get a home loan before the crisis. After the crisis, it became much harder to get a home loan, as banks were worried about people's credit worthiness. And so if banks didn't have customers to make loans to, what are they going to do? They're going to park their funds at the Fed in the form of excess reserves. All of those factors go into the reasons why excess reserves increased as much as they did. Okay, you guys have any questions about that one? All right, so I've got some time left in class today. What I would like to do now is go back over to let's go back over to these extra problems that should be available on Blackboard and work through a problem that's a bit more challenging, that will really test your understanding of this deposit multiplier stuff. For those of you here and for those of you participating remotely, you're very likely to see a question like this on your first lab assignment, which by the way is going to be next Wednesday, I guess. We have Monday off for Labor Day. So on class on Wednesday, we're not going to talk about any new material. I'm going to give you guys a lab assignment that hopefully you'll be able to finish during class. And the folks who are participating remotely will just have to email that to me by the end of class. It's an open book, open note lab assignment. There will be some kind of open-ended questions like the ones we've done in class. There's also going to be some questions that require you to go out to the website of the Federal Reserve Bank of St. Louis and look at some actual data. The instructions will be very clear on the lab assignment, and that's super easy to do. And if anybody's confused about that, I can certainly take a few minutes during class on Wednesday to demonstrate how to do that, okay? You can kind of think about this as I know the first test isn't some time away, but it's kind of like a pre-test, all right? Okay, so with that said, why don't you guys take a look at number 3 here. So here's some data on a fake economy. Currency is 100 billion, bank reserves are 200 billion, checkable deposits 800 billion, excess reserves 40 billion. Here's what I want you guys to figure out. Let's suppose that the Fed conducts a $10 billion open market purchase of US Treasuries. How much is that action going to affect the money supply? How much will it affect the currency versus the checkable deposit component of the money supply? And how does it affect required versus excess reserves? So why don't you guys take a few minutes there, let's say 7 or 8 minutes, and try to work through this problem. It's a little bit more complicated than the one from the notes. And then as we work through this together a little bit later, make sure you save this stuff because you might very well see a problem like this on your lab next week. Okay, hopefully you guys had enough time to work through at least some of it. I don't expect you to have done the whole thing, but let's go ahead and start working at least the first parts of it here. So I've got the basic data from this problem. So currency is 100 billion, reserves is 200, demand or checkable deposits are 800, and excess reserves are 40 billion. The first part of the question asks us what happens to the total money supply if the Fed were to conduct a $10 billion open market purchase of security. Okay, so first off, if the Fed conducts an open market purchase, they're buying securities from banks and they're paying for it by injecting bank reserves into the banking system. So bank reserves are going to rise initially by 10 billion. The question is then, how much is that going to increase the overall supply of money? Well, what's the first thing we need to find out then? Is what the money multiplier is in this example, right? Now remember, the money supply is equal to the money multiplier times the monetary base. So the money multiplier is just the money supply divided by the monetary base. Or you can use the brute force formula that we derived in class. Well, what's the money supply? That's currency plus checkable deposits over the monetary base. That's currency plus reserves. Okay? Do we know what currency is? Yes, it is 100 billion. Do we know what deposits are? We do. It's 800 billion. Currency again is 100. And what are total bank reserves? We also know that from the problem. It is 200 billion. So this is what? 900 billion divided by 300 gives us a money multiplier of 3. How many of you guys got to that step? Got the right? Okay, good. We're on the right path then. We now actually have all the information we need to figure out what happens to the money supply, right? The change in the money supply should simply be the money multiplier times the change in the monetary base, right? Now the Fed, by engineering this open market operation, increases the monetary base by $10 billion by paying banks $10 billion worth of bank reserves. Remember what the monetary base is. It's currency plus bank reserves. And so the total change in the M1 money supply here should be $30 billion. And so the money supply has gone from, what was it originally? 900 billion to 930 billion as a result of this open market operation. And how does that work? The Fed conducts an open market operation. Banks receive new reserve balances. They start to lend out some of those reserve balances, holding some in excess reserve. That money gets spent in the economy. Some of it gets redeposited into the banking system. Some of it gets held in the form of currency. What's redeposited is then loaned out to other investors, while some of it is held in excess reserves, et cetera. And you get this deposit loan expansion process that ultimately raises the money supply by 30 billion. So the $10 billion increase in bank reserves through the money multiplier process raises the money supply by $30 billion. How many of you guys got that part? Couple, okay. What's the I guess the more challenging part of this question is the next, and that is what happens to the currency versus deposit component of M1? So in other words, what does the change in currency look like? What does the change in deposits look like? Okay, to answer this question, we want to take we want to make use of some of these ratios that we're assuming are constant in the problem. So what is the currency to deposit ratio in this problem? Currency is 100 billion to start off with, and deposits are 800 billion. That ratio is equal to 0.125. We're going to assume that that ratio stays constant. It's not a great assumption given what we saw in the data, but to work this problem, we can assume that it's constant. Why does that help us? If the currency to deposit ratio is equal to 0.125, then that means currency is equal to 0.125 times checkable deposits. Everybody with me? Okay. Now, what is the money supply? Again, the money supply is equal to currency plus deposits. What I want to do is I want to substitute this expression for currency into that equation. And I get that the money supply is equal to 0.125 times deposits. That's the currency component plus checkable deposit. In other words, the money supply is just 1.125 times checkable deposit. That's helpful for me. Why? Because I know how much the money supply has changed by, so I should be able to figure out how much deposits are going to change by. The money supply changed by what? It was 30 billion, right? So the new money supply is 930 billion. That should be equal to 1.125 times whatever the new value of deposits is. And if I flip that equation around, you'll find that deposits, if I did the math right here, is 826.67 billion. So that requires a few lines of algebra, but it's still pretty straightforward if you make use of the currency to deposit ratio. And so how much have deposits gone up by as a result of this injection of $10 billion worth of bank reserves? Deposits were initially 800 billion. Now they're 826.67 billion. So there's been a 26 2/3 billion dollar increase in checkable deposits. What about currency? Well, that should be straightforward. Currency is just 0.125 times D. So currency is just 0.125 times 826.67, which I believe is $103.33 billion. Again, that's 0.125 times the new value of deposits. Okay, so how much have currency holdings increased in our economy then? Well, what was currency originally? It was 100 billion. Now, after the open market operation, currency in the economy is 103.33 billion. So currency has increased by 3 1/3 billion dollars. You see what's happening here? The central bank injects $10 billion worth of bank reserves into the banking system. Some of it gets loaned out, some of it gets held in the form of reserves. Then the non-bank public gets their hands on those funds and redeposits some of it, but some of it gets held in the form of currency. Well, once that process plays itself out, currency has gone up by 3 1/3 billion. Question over here, yeah. Yes. You can do it that way. There's more than, I think there's probably more than one way to figure out the arithmetic here. If you prefer looking at it that way, where it looks to me like you're talking about you know, like at this equation, think about the change in money as being the change in currency plus the change in deposit. Well, if you can, you know that the change in the money supply is 30 billion. If you can figure out that the change in deposits was 26 and 2/3, then you can figure out the change in currency. You can work with it that way or use these ratios like I did. Okay, the last part of the problem asks us to account for the change in required and excess reserves. All right, the required reserve ratio, remember, is required reserves divided by deposits. What are required reserves in this economy? Well, what do we know? We know that total bank reserves are 200, excess reserves are 40. So what must required reserves be then? The difference between them. So required reserves were 160 billion divided by total checkable deposits of 800. And so we can find the required reserve ratio as 160 over 800. And that is equal to 0.2, a 20% reserve requirement. Excess reserves to deposits can be calculated as 40 billion. Again, that's given in the problem, divided by 800 billion. And so the excess reserve to deposit ratio then is just going to be, I believe, 0.05. Once we have those two ratios, we then should be able to figure out how much required and excess reserves have changed by in this problem. I've only got about 3 minutes left, so I want to try to get through this. So required reserves then have to be equal to 0.2, that's the required reserve ratio, times deposits. And excess reserves have to be equal to 0.05 times checkable deposits. Well, we know what the new value of deposits is in this problem. It's 826.67 billion. And so the new value then of required reserves and excess reserves, if we plug this stuff into a calculator, would be 165.33 billion for required reserves and 41.33 billion for excess reserves. And so required reserves have increased by how much since before the open market operation? They've gone from 160 billion to 165.33 billion. So that's a plus 5 1/3 billion in additional required reserve. How about excess reserves? They were originally 40 billion. Now they're 41 1/3 billion. So that's a plus 1.33 billion for excess reserves. If you've done this problem right, the accounting should balance perfectly, okay? Multiple deposit loan expansion is going to continue here. So the money supply will be increased until the $10 billion original injection of bank reserves gets absorbed into the economy in one of three places, in the form of required reserves, excess reserves, and currency. Look what happens when I add together the extra currency plus the extra required reserves plus the new excess reserves. What do I get? 3 1/3 plus 5 1/3 and 1 1/3 should give me 10 billion. So the initial injection of $10 billion in bank reserve that was created by this Federal Reserve action, the open market purchase of treasuries or whatever, is going to expand the money supply through the multiple deposit loan creation process until every dollar of that $10 billion injection finds its way into either currency, required reserves, or excess reserves. Once that process stops, loans and additional deposits will not happen anymore, and the money supply increase will cease. And this problem, it's an additional $30 billion worth of total money. The assumption we've made in this problem, of course, is that these ratios, C over D, ER over D, etc., are constant. These are dubious assumptions, particularly since we see what's in the data, that for instance, the excess reserve to deposit ratio has not been stable. So I want to point that out because I don't think it's important to understand that this model of the money supply process is not really useful as a means to predict how Federal Reserve actions will impact the money supply. It's no good for that because those ratios aren't really stable through time. What the model is useful for is helping us understand what's at the heart of the money supply process. It's the multiple deposit loan creation mechanism in our economy, while accounting for the fact that banks are holding excess reserves and that the public holds some currency as well. It helps us understand kind of the intuition behind what's driving the money supply in our economy. It's not a very good model for trying to forecast or make predictions about the money supply. So be careful about how you interpret and use the model. Okay, I'm a minute over. I apologize for going late. I will send out an email with more details about the instructions for the lab next Wednesday. Otherwise, you guys have a good weekend and a happy Labor Day.